Today we're going to focus on part 1 of a 2-part series of tutorials about making a fancy laser effect. In this tutorial, we'll cover making beams using Talos VFX, as well as whatever else may be needed to make this look as realistic as possible. I was going for a mix of Ghostbusters-style intercrossing beams, with a single glow plasma laser in the middle. And I'm actually really pleased with the final result. Let's set this up so that we only have one particle emitted for now, in order to make it easier to work with. We'll start with a beam position module, which is a great adapter for converting a simple from and to point setup, basically a segment, into a rotation, size, and position values that will position particles exactly to fit that segment. Now, we can use these yellow points in the preview window to change the from and to values to our liking. You can see how the particle effect just grows and fits the segment. Next, we want to change how our particle is being rendered. This time we're going to use a beam renderer. Beam is sort of a segment or a polyline that is broken apart into tiny segments, which we can specify with an interpolation points value. I'm going to set it to 50. More points means better details, but at the cost of performance. Offset is an important value as it tells each point how much it should offset from its original position. Currently, we are only using 0 point of curve and applying that offset to x offset of all midpoints. That's why it all moves together. I'll connect it to the y of a vector module so we can move it up and down instead. And you can see that making this line into a curve just confuses things, applying different offsets to different beams. Instead, we want to control individual beam point offset. The way it's done isn't exactly intuitive, but there is a system module that has a primary seed value. And the value of a primary seed will be different for each point of the beam. It will be a number between 0 and 1, depending on where our point is in the beam in terms of its order. 0 is left and 1 is right. In this case, the 25th point will have a primary seed value of 0.5. Now if I make a curve, it will now offset my beam exactly the way the curve looks. Now, since we want this to be random, a noise module is our best tool for that. So it makes sense to use that instead of a curve module. But I'm going to keep the curve module and multiply our noise with it so that we have control over the strength of our noise later. Lastly, we want the offsets to be animated. So I'm going to use our particle lifetime value using the system module to get this into the mix. And now it looks like an oscillating sound wave. I can use our curve to change the strength of this stuff in order to make it a bit more crazy on the left and a bit more calm on the right. This is definitely starting to look like something now. I just need to add some more particles. Transparency control will smooth our transition from beam to beam as they die and spawn. Now beyond offset, we can also have similar control over beam thickness, color, and transparency. It's very important to connect them all again to primary seed, so this works per point instead of per beam. We want this more transparent to the left, so it's a simple curve. And in terms of color, I'm going for a more dark orange on the right, and purple or red on the left as they hit the wall, and just a bit of variety for thickness as well. I'm also going to multiply our time by a small number, so we can make them oscillate a little bit slower and calmer. Okay, we're done with our beam. That was the hard part. And the cool thing about beam position modules is that we can easily rotate it around, which makes this a lot more dynamic when we get back to this in the next tutorials. That being done though, our next step is shader for mid-laser part. The technique is pretty simple here. First, we're going to need a vertical gradient, which is the green channel of a UV node. So I'm just going to take UV node, insert them into color node, and then extract green. We'll also need the same gradient, but inverted. And for that we have one minus node. Powering them both to the power of 4 and then adding together will make a sort of inverted laser. And then inverting this one more time will make it look white in the middle and black on the outside. Power it one more time, and we will get the texture that looks like a glowing laser. At the top, I will make another element for the laser shader, which is its distortion animation. For that, we'll use Voronoi noise, and that will just tile and move to the left using time. Multiplying our two parts will give us the animation we're looking for. I'm also multiplying this vertex color so we have control over the color of our laser later in the effect. And since it's a bit dark, multiplying it by 2 or 3 will bring up the brightness. Alternatively, you can use a brightness and contrast module to do the same thing. Now back to our effect. I just made a new emitter for the laser. Before using our shader, let's learn to draw a simple line first. I'm going to spawn some particles to get things going, and then use our beam position module again in order to make a controllable from-to thing. Except for the size, which we want to be dynamic in width, but with a static height to make it look like a thin line. That way we can render a line of our preferred thickness and control its from and to points. Now for its texture. We're going to load the shader we just made and see how it looks. It looks like a white line with no glow because it's it's too thin, and it has no color applied. So let's fix that now. I'm gonna go for a crazy rainbow of colors here because, well, why not? And finally, we'll make it thicker, which really reveals the beauty. Next, we'll add some fancy stuff to make it all more detailed and cool. That would be a sparks effect on the wall where the laser hits it. And then we can also add some overall glow and maybe light sources at target and source. The final effect looks pretty cool, and there are many ways we can customize this. Change color, make it more active or smooth. In our next tutorial, we're going to be making this a lot more dynamic and attach it to a spine animation so our laser can follow the direction of a gun. We'll also go over the basics of global variables, as well as to learn the BVB tool, which is a huge part of Talos, and helps connect particle effects with skeletal animations. Don't forget to subscribe to our channel, and stay tuned for the next part of the laser beam tutorial. We'll see you soon.